Okay, so this is where we left off yesterday. Our answer was x equals 2 square root of 5, correct?
Yeah, there's a trash can, right?
Correct?
Yeah.
There's something I forgot to talk about with square roots. If I take the square root of something, I've got to account for the positive and the negative value. So this is actually going to be plus or minus 2 square root of 5. Okay? So let's talk about it real quick. Let's say I have this equation. X squared equals 9. How would I get x by itself? For x squared equals 9.
Square root.
Take the square root of both sides, right?
Yeah.
So what's the square root of 9?
3.
3, but like I said, we got to account for the positive and the negative, and here's why. If I plug my values back in, it should make the equation 2 true, correct?
Yeah.
So if I plug 3 in, what's 3 squared?
9.
Is that a true statement?
Yeah.
Yes, it is.
Could be.
3 is not the only thing that I can square and it becomes 9. If I plug in negative 3, what's negative 3 squared?
9.
9. Is that true or false statement? True. So I've got 2 solutions there. Does that make sense?
Yeah.
So when I take the square root of something, I've got to account for the positive and the negative value. We okay with that? So letter A is not just 2 square root of 5, it's plus or minus 2 square root of 5. Does that make sense?
Yeah.
I forgot to mention that yesterday. We okay with letter A? Can I erase and move to letter B? Letter B. Trying to get x by itself, correct? It's my first step to get x by itself. If I have 3x squared plus 9 equals 0.
Subtract 9 from both sides.
We'll subtract 9 from both sides. I'm moving stuff away from the x. So first off, I'm trying to get the term containing x by itself. So I'm trying to get 3x squared by itself. What's 0 minus 9?
Negative 9.
Negative 9. Everyone okay with that first step? What's my next step to get x by itself?
Divide both sides by 3.
Divide both sides by 3. X squared equals
3. Negative 3.
negative 3. And how do I get x by itself now? Take the square root of both sides. So what would x equal?
3. 1 square root of 3.
Huh?
Square root.
I'm sorry, I can't hear you.
Like put the square root and then negative 3.
Okay, let's talk about this real quick. Let's talk about what square root means. Square root means that I'm looking for a number multiplied by itself to give me that number under the radical, correct?
Yep.
Is there any number that when I multiply it by itself, it gives me negative 3?
No.
Why?
It's not a prime number.
It's not.
Well, it could be a decimal, right? To multiply a decimal by itself. But it's a negative under my radical, correct? I'm looking for a number times its exact self. So either a positive times a positive or a negative times a negative, correct? What's a positive times a positive going to give me? A positive, not a negative 3, right? What's a negative times a negative going to give me? Positive, not a negative 3, right? So is there any number that I can multiply by itself to give me a negative 3? No. So this will be no real solutions. And here's why we have to say no real solutions. Because later on, can't remember if it's this chapter or a different chapter, but later on in this class, we're going to learn about imaginary numbers. Imaginary numbers, we can take square roots and negatives. But right now, today, we're just talking about real numbers. So there's no real number that I can multiply by itself to give me negative 3. So this is no real solutions. Does that make sense for our real numbers?
Yeah.
You cannot take the square root of a negative number when you're dealing with real numbers. Okay? So that's what I'd write for letter B. Questions on B? I know y'all are real excited about imaginary numbers, but
That's not even math, it's just fake numbers.
can I erase and move to C? Okay, here we go. 2 over 5 times x plus 3 squared equals 5. Trying to get x by itself. What would be my first step here?
Solve your parentheses.
I can't distribute because that parentheses is tied down with the exponent of 2. Okay?
Do 3 times what? 3 times 3?
Is it a Y? Or
Huh?
another
That's
parenthesis?
what?
This is 2 over 5 times x plus 3 squared equals 5. That's our problem on C.
Multiply x plus 3 by itself.
Say it again.
Multiply x plus 3 by itself.
There's a way we can do it without doing that. That's going to probably require some extra steps.
Just fact.
How can I get rid of that 2/5 with my parentheses?
Subtract.
If it's 2/5 times a set of parentheses, divide it on both sides. And divide both sides by 2/5. If I divide it by 2/5 over here, it's going to cancel out. Whatever I do to one side, I have to do to the other. So I would get x plus 3 squared equals, someone type in 5 divided by 2/5. 25 over 2. Good stuff. We love fractions, don't we? Yeah, we do. You guys know everyone loves fractions. Okay,
Personally, don't.
what would be my next step? We got x plus 3 squared equals 25 over 2.
Distribute the exponent.
Not distribute the exponent, I can't do that. How do I get rid of an exponent? Or an exponent of 2? Square root of both sides, right? Everyone okay with that?
Gosh darn it.
So, that would get rid of that exponent of 2 with x plus 3, correct? So I'd get x plus 3 equals plus or minus. Now, here's another rule of radicals that hopefully you guys remember. I don't know if you do or not. If I've got two things under a radical being divided, I can split them up into their own radicals. Just like that. That's a rule of my radicals. Rule of my square roots. Okay? We'll deal with that in a second. How would I get x by itself now? Subtract 3. So x equals, I'm going to erase this stuff over here. Negative 3 plus or minus, what would the square root of 25 be? 5 over square root of 2. Does everyone see that? I went ahead and simplified the square root of 25 in my numerator to become 5. Everyone okay with that? Yes.
What's that sound in?
Say it again.
What does that sound in?
That's a plus or minus. Remember when we take the square root of both sides? We've got to account for the plus or the positive and the negative value.
Okay.
Okay? So, I get x equals negative 3 plus or minus 5 over the square root of 2. Another curveball for you here. Just hope you're ready for it.
I'm ready for it.
For what?
I'm ready for a fastball.
Okay, here comes the fastball then.
I'm ready for it.
In order for a term containing a square root to be in simplest form, I cannot have a radical in the denominator of my fraction.
What does that mean?
We did it.
Is the denominator the top or the bottom of the fraction?
The bottom.
Bottom. So I can't have a radical in the bottom.
And that's a radical.
That's a radical. It's a square root.
So,
So I've got to somehow get rid of that radical. You may have learned about this in Algebra 1. I doubt you guys remember it. So we're going to cover it real quick. I got to do something called rationalizing the denominator.
rationalizing this.
Stage.
So I've got to multiply by a special form of 1. So that way I keep this equivalent. So what I'm going to do is multiply the bottom by the square root of 2. Is that what you said?
Good job.
Yeah.
You did?
Yeah.
Oh, I didn't hear you say it. I'm sorry. What would I have to multiply the top by?
I swear I did.
The same thing.
Same thing. Because square root of 2 over the square root of 2 is 1, right? Anything over itself is 1. So I'm multiplying 5 over square root of 2 by this special form of 1. So it's keeping it equivalent. Does that make sense? And we'll see how this gets rid of the radical in the denominator. So this isn't changing negative 3 at all. Negative 3 stays the same. I still have my plus or minus sign. I'm just changing 5 over the square root of 2. Okay? So fractions I multiply straight across, correct?
Yeah.
So if this had a radical in the numerator, I can multiply the numbers under the radical. But is there a radical?
No.
No, so this just stays as 5 square root of 2. So 5 times the square root of 2 is just 5 square root of 2. You okay with that concept?
Nice.
In the bottom, I can multiply the numbers in the radical. So what's 2 times 2?
4.
So it becomes the square root of 4. What's the square root of 4? 2. So everyone see how my radical went away?
Yeah, that's cool.
So now that would be in simplest form. So this would be my answer. X equals negative 3 plus or minus 5 square root of 2 over 2. If it wanted specific answers, like decimal answers, I could type each of these into my calculator individually. I would type in negative 3 plus 5 square root of 2 over 2 into my calculator, and it'd give me a decimal. Then I would type in negative 3 minus 5 square root of 2 over 2 to get that decimal. Does everyone see that? This is good stuff, isn't it? Kind of okay with that concept. Kind of. Did some of it make a little bit of sense?
A little, but.
No? Okay, great.
This is all.
Maybe I can do some more on the assignment with y'all whenever we get to them.
Oh, we're
Okay.
gonna
If we finish the notes today, you'll get the assignment today. If not, we'll get it Monday.
Start asking questions on the letter.
Questions on letter C?
Thank you.
I
Questions?
get it, but I'm very confused.
Hannah said she didn't understand it at all.
I was in here yesterday.
Oh, she has.
So, this is how we solve quadratic equations using square roots. We try to get the x by itself. When we get the x squared term by itself, we can take the square root of both sides. Or if we get to here, an x plus 3, please quit talking, an x plus 3 squared, or something like that, I can take the square root and then finish it out, like I did.
Why
Okay.
can't the square root be on the denominator?
Because that's the definition of simplest form for a radical, a term containing a radical. Yes?
Is that a just different examples?
Say it again.
Is on top what like different examples? How many is this an 8 minutes?
Up here? So, these are my two answers that I just got. I just split them up instead of writing plus or minus. I was saying if it wanted more specific answers, like decimal answers, I could type these into my calculator like this. Negative 3 plus 5 square root of 2 over 2. That'd give me one of my specific answers as a decimal. And then I would type in negative 3 minus 5 square root of 2 over 2. Because I'm accounting for the positive value and the negative value.
Oh, we don't have to do that?
Not unless it asks you to. I'm okay if you leave it like this.
Do you want us, so you want it to be like that, or do you want us to write it?
Like this.
It don't matter.
Just
That's
like
fine.
a
That's fine. Just like this.
Okay, okay.
So does
The
5
boxed in
square root
answer.
of 2 not have a solution?
Say it again.
5 square root of 2 does not have a solution.
Yes, it does.
It would be a decimal, wouldn't it?
It'd be a decimal. I'd get a decimal.
What
Oh,
about
we don't have.
what about that over 2? Does like do those 2's not?
So, this down here can break, we're counting for the positive and the negative value of 5 squared root of 2 over 2, correct?
It would have been the same thing.
So I have two answers. I split them up here. Here's the positive value, negative 3 plus 5 squared root of 2 over 2. Here's the negative value, negative 3 minus 5 squared root of 2 over 2. If you were getting more specific answers with decimals, that's how you type it in your calculator.
You said if it
you
asks
do
for
that?
that, you have to put that? Is that what you said?
I would type this in my calculator
Oh, okay.
if it asks for a decimal answer. Okay? and that'd give me some long decimal.
So it's like an actual.
And I could round to whatever number it asks me to round to.
Like plus or minus. Like you can actually have that as an answer.
Yeah, yeah. Okay,
Interesting.
okay, I'm moving on.
Oh, I thought we.
Zero product property. We've talked about this before. We have talked about this before. When the left side, shh, please quit talking. When the left side of ax squared plus bx plus c equals 0 is factorable, I can factor it. That's what factorable means. We spent past couple weeks factoring, correct? So when it's factorable, you can solve the equation using the zero product property. So we've talked about the zero product property before. Here's what it is specifically. If the product of two expressions is 0, then one or both of the expressions must equal 0, right? So if I have this times this equaling 0, I know one or both of them must be 0, right? For it to equal 0. Right?
Yeah.
If a and b are expressions, and I have a times b equaling 0, I know that either a equals 0, or b equals 0, or they both equal 0, right? Because a times b is 0. Anything times 0 is 0, so I know one or both of them must be 0.
Yeah.
That's the zero product property.
Makes sense.
That makes sense.
No, yeah, it does.
We've talked about that before, so hopefully kind of remembering this a little bit. Everyone kind of understand the zero product property.
Yeah.
If I have two things being multiplied by each other and they're equal 0, I know one or both of them must be 0.
Right.
Right?
Yes.
Okay. Okay. So solve x squared minus 4x equals 45 by factoring.
Okay. But you went from A plus B or something.
Okay, so over here, a and b are expressions.
Okay.
So that'd be like, if I take this and factored it, I'd get x plus something
Right.
times
So
x
that
plus
would be
something.
A.
So x plus something would be a.
And then
This other x plus something would be b. Okay?
Yeah.
That's what a and b are representing there. Does that make sense?
Yeah.
So, keep this in mind. Ax squared plus bx plus c equals 0. Is this in that form? Ax squared plus bx plus c equals 0.
Yeah.
It's not.
Oh, okay.
I don't have ax squared plus bx plus c equaling 0, do I? I've got ax squared plus bx equals 45. So how can I get 0 over here?
Add.
Is everyone paying attention?
Add.
How would I get rid of this 45 over here? It's a positive 45. How would I get it to 0? Subtract 45. Whatever I do to one side,
Because it equals 0.
I have to do to the other.
Yeah.
I would get, can I combine negative 45 with anything on the left side?
No, you cannot.
No. So I just tack it on to the end. Now is this in the form ax squared plus bx plus c equals 0? Yes, it is.
Yeah.
My a value is 1, my b value is negative 4, my c value is negative 45.
And then it equals 0.
Right? And it equals 0. So this is in this form. Okay?
So now.
So that's not all I have to do. Now we factor it
Like we did.
like we've done before.
Okay.
What number is in front of x squared? 1. How many terms do I have? 3. Am I factoring by grouping?
No.
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 Factoring by grouping would involve 4 terms. Am I factoring the difference of squares?
No, you're not.
No, because that would involve 2 terms, right? Am I sliding and dividing?
No, you're not.
No, because I got a number, I have 1 in front of x squared, right?
Yeah.
So I'm just factoring normally like we learned first off the bat. So I create my 2 sets of parentheses.
Yes.
What's my variable? X. Everyone okay with that?
This is what we were doing before. I knew that.
We did this a long time ago.
Like Monday?
We did this a while back.
So Monday was what time?
So I create my t-chart. Shh. What's my c value?
Negative 4.
Negative 45. Okay, there's too much. What's my b value that goes over in the second column? Negative 4. What are my signs going to be in the parentheses? What does the minus sign in front of the c value tell me?
They're gonna be different.
They're going to be different. One's a plus, one's a minus. Everyone good? Okay, I'm looking for two numbers that multiply to give me negative 45, add to give me negative 4. What are some numbers that multiply to give me negative 45?
Negative 15 and 3.
What Journey said.
Negative 15 and 3?
Yep.
Negative 15. Positive 3. If I add those, what does that give me?
Negative 4.
Negative 12.
Negative 12. Is that what I want?
No.
No. Raise your hand. Can you give me two more numbers?
I did.
Negative 9 and what? Positive 5. What's negative 9 plus 5? Negative 4. Is that what I'm wanting?
Yep.
Now pay attention to where you're putting your numbers. I get x plus what?
Plus 5.
Plus 5 because it's a positive 5 that I'm dealing with. X minus
9.
9. Everyone okay with that?
Yes.
Have I now factored this completely?
Yep.
Yeah, because I'm not sliding and dividing, am I?
Why? 0 just stayed.
So I know that's... Say that again.
I said why.
Why am I not sliding and dividing? Because I have 1 in front of x squared.
Oh, so if you have a number in front of it, then you slide and divide.
Yep.
If you don't, then you don't do it.
Yep. So I factored it. Can I erase my t-chart?
So the 0 just stays.
0 stays there. So let's use our zero product property now. X plus 5 is my A. Right?
Yeah.
X minus 9 is my B. They're being multiplied together and they equal 0. So using my zero product property, I know one of these factors or both of them must equal 0, right? So what can I do? Set them both equal to 0. Set both factors equal to 0. Does everyone see that? Now I can solve both of those equations. X plus 5 equals 0. How do I get x by itself? Subtract 5 from both sides. What does x equal? Negative 5. There's one of my answers. X minus 9 equals 0. How would I get x by itself? Add 9. X equals 9. There's my two solutions to my quadratic equation. Questions on that? Did that one make more sense than the other method?
Yes, very much. Can we just do this?
Are we any questions on example 3? We all right? Can I move on?
Yes. I don't think I'm doing fine.
Zeros of a function. Don't fret here. This is pretty similar to what we just did. So you know the x-intercepts of the graph of f of x equals a times x minus p times x minus q are p and q. So this, hold on. Please quit talking. This is representing a quadratic equation. It's just factored. Okay? Whenever we were solving by graphing, what were my solutions of a quadratic equation?
The line.
When we were graphing, what were my solutions?
X-intercept.
Where it crosses the x-axis, my x-intercepts, right?
Yep.
So, in factored form, my factors are representing my x-intercepts. Okay? So right here, x equals negative 5 is an x-intercept of this graph. X equals 9 is an x-intercept. Because these are my solutions. It's where they cross the x-axis. Right?
Yes.
And in the parentheses, they had opposite signs from what their actual answer is, correct?
Yeah.
This is x plus 5, but x actually equals negative 5. This is x minus 9, but x equals positive 9 is actually my solution. Right? So here, this is just factored form of a quadratic equation. So the x-intercepts of this graph are positive p and positive q. Right? Does everyone see that connection between this one and this one? It's the opposite sign of what's in parentheses. X plus 5, x actually equals negative 5. X minus 9, x actually equals positive 9. X minus p, x actually equals positive p. x minus q, x actually equals positive q.
So it's just the opposite.
Right. Because whenever you set up your equations using the zero product property, you're using your inverse operations to move it to the other side. Right?
Yeah.
Does that make sense?
Yes.
So we know that the x-intercepts of the graph of this quadratic equation are p and q. Right? Because those are my solutions, those are my x-intercepts. Because the value of the function is 0 when x equals p, if I plug p in here, what's p minus p? 0. 0 times everything is 0.
Yeah.
So the value of the function is 0 when x equals p, right?
Yes.
And when x equals q, because what's q minus q?
0.
0. 0 times everything 0. Everyone see that? When I plug p in here, I get 0. When I plug q in here, I get 0. So the value of the function is 0 when x equals p and when x equals q. Everyone see that? When I plug my solutions in, I get 0. The numbers p and q are also called the zeros of the function. So there's multiple words for our solutions here. I can call it my solution. I can call it my root. Remember we called them roots yesterday. And I can call them zeros. So if it asks me to find the zero of a function, it's just wanting me to solve the x value, or solve for the x value when f of x equals 0. So I'm just finding the solution. I feel like I just did a lot of talking and you guys are just staring at me blankly.
That's exactly what it's about.
So, there's 3 different words for solutions. A solution is a solution. A root is a solution. And a zero is a solution. There's just 3 different words for calling it a solution. Okay? So here's our example. Find the zeros of f of x equals 2x squared minus 11x plus 12. Yes? Yeah, I'm about to go back to it. I'm going to let you write down this problem first, and we're going to go back and look at the previous slide. Find the zeros of f of x equals 2x squared minus 11x plus 12. What's another word for zeros?
Root.
Roots or solutions. I'm just finding the solutions of this quadratic equation. This quadratic function. Everyone got this function written down? So I know the x-intercepts of my function that I just wrote down. The x-intercepts are going to be whatever it is factored, and I solve for the zeros. Okay? So I've got to set my function equal to 0, and then factor it and use my zero product property. Very similar to what I did right here. Everyone okay with that? So I'm setting it equal to 0. Because I'm finding these zeros of the function. I'm finding the values of x for when my function is 0. Okay? So, what am I going to have to do with 2x squared minus 11x plus 12? What am I going to have to do with it?
Get x by 7.
Nope. Starts with an F. Factor. There we go. Let's factor 2x squared minus 11x plus 12. Do I have any GCFs I can pull out?
No.
No. Is there 4 terms?
No.
No, so I'm not factoring by grouping. Is there only 2 terms and I can take the square root of A and C?
No.
No, so I'm not taking the difference of squares. Is there a number besides 1 in front of x squared?
Yeah.
Yes, so what am I going to have to do?
Slide divide.
Slide and divide. 2 times 12? 24. Everyone okay with that? We're just factoring 2x squared minus 11x plus 12. 2 sets of parentheses. What's my variable?
X.
X. It's a plus sign before my C value. So are they going to be same or different?
Same.
Same. What are they both going to be?
Minuses.
Minus. Now let's create our T chart. 24 is my C value. What's my B value? Negative 11. Finding 2 numbers that multiply to give me 24. Add to give me negative 11. What things multiply to give me 24? And we can only deal with the negatives. We don't have to deal with positives. So 2 negatives that multiply to give me 24.
Negative 12, negative 2.
Negative 12, negative 2. What do I get when I add those? Negative 12 plus negative 2.
Negative 8, negative 3.
What's negative 12 plus negative 2?
Negative 14.
Negative 14. Is that what I want?
No.
No.
How you doing?
Yes.
Negative 6, negative 4.
Negative 6, negative 4. What do I get when I add negative 6 and negative 4?
Right.
Negative 10. Is that what I want?
No.
No. Yes.
Negative 8, negative 3.
Negative 8, negative 3. What do I get when I add those?
Negative 11.
Negative 11. Negative 8 times negative 3 gives me 24. Negative 8 plus negative 3 gives me negative 11. Is that what I'm wanting?
Yes.
Yes, it is. So I get x minus 8, x minus 3. Questions there? Can I erase my t-chart?
If you want to.
I do want to.
I don't want to. Dude, no way. I like your shirt.
Okay. Sliding and dividing. What's my last step here?
Got it. Bottoms up.
Nope, not yet.
No.
Divide by.
Divide by.
What? 2. The number that I slid over earlier. I got to divide by the number I slid over earlier. So 2.
Yeah, no. So that hardly, by the way.
8 divided by 2.
Negative 14.
Can I simplify 3 over 2 any?
No.
No. Now what do I do? Bottoms up. Only if I have a fraction left over. If there's not a fraction, it just stays. So I get 0 equals x minus 4 and 2x minus 3. Everyone okay with that? Is this now factored completely?
Yes.
Yes, actually.
Yes, it is. I factored it completely. Now, it's set equal to 0, right?
Yeah.
How do I solve this?
You gotta do the thing.
Flip the sign.
So set them both equal to?
0.
0. It's my 0 product property, right? I got 2 things being multiplied together, set equal to 0. I know one or both of them must be 0. Can I erase the stuff to the left to give myself some more room?
Sure thing.
So x minus 4 equals 0. 2x minus 3 equals 0. So x minus 4 equals 0. How do I get x by itself?
Add 4.
Add 4. So x equals 4 is one of my solutions. We good with that?
Yeah.
2x minus 3 equals 0. What's my first step to get x by itself?
Add 3 by.
Add 3. So 2x equals 3. Is x by itself?
No.
How do I get x by itself?
Divide
Divide by 2. So x equals 3
over 2.
halves. There's my solutions. There's my zeros. There's my roots. Those are the zeros of my function. If I plug these values in, it'll make my function equal 0. Do you guys believe me, or do you want me to do it? Plug it in and show you.
We believe you.
We believe
Plug it in.
So I plug 4 in for x, it'll give me 0. If I plug 3 halves in for x, it'll give me 0. It'll equal 0. Okay?
You beat that.
Questions on example 4?
So the first one will be 4, and the second one will be 0, 2.
Say it again.
So the first x.
Yeah, it's my first solution, 0 or root. But in this case, we're calling it a 0 because it told me to find the zeros of the function. Which just means if I plug it in, it'll equal 0.
But like the first x would equal
Yep.
4.
So where is this parabola crossing the x-axis?
4.
4 and
3 over 2.
3 over 2. So everyone making that connection. That the graph, the parabola, the solutions are where it crosses the x-axis.
Wait,
So it's crossing the x-axis at 4 and 3 over 2.
so 3 over 2 would just be like.
That'd be 1.5. Okay? So if you wrote it as 1.5, I wouldn't count it wrong. It's the same thing. Same thing. Yes?
Can you come back to the last slide?
Yeah. Everyone understand that 0, root, and solution are all meaning the same thing. So we took our function and we got it into this form right here. Right? We factored it. It's factored form. And then we set it equal to 0. because it told me to set my function equal to 0, use my zero product property to solve it, and find the zeros of the function. Does that make a little more sense than when we were just on this slide? Okay. So if you're finding the zeros of the function, what do? Set the whole function equal to 0. Factor it. Solve for x using your zero product property.
Yeah.
We okay? Questions, comments, concerns? What do we have next?
There's another slide. We're covering them all. It's so
Okay. I believe that concludes our notes for, is this 3-3?
3 foot.
Part 3.
3-3. I believe that concludes our notes for 3-3. We're ready to receive the assignment from good old Coach Matt.
No,
What's Coach Matt going to do?
I don't think you're gonna give us.
What's he going to do?
He's gonna say, have a good weekend. Let's wait till Monday.
Are you sure?
I'm
We
pretty
will
sure.
not like you.
Hey, don't be
Please
too
don't.
sure.
It's
I'm
a lot
pretty
to
sure.
remember.
I mean, we got enough time in
I'm not
class.
gonna do it either way.
Don't. I will start crying if you do.
Uh-oh.
I'm gonna be honest, if you do, I'm not doing it. I don't care.
That's just rude, Anna.
I'm just gonna start crying. Please don't. Get away from the desk. I swear. I'm gonna throw this ball.
Okay, listen. Let me explain what we're going to do. We're going to get the assignment today. Monday. We're going to get the assignment on Monday in class. Okay? Don't forget everything we learned the past 2 days. So, listen, quit talking, put your phones away.
Oh my.
We need to come prepared Monday with a good attitude,
Right.
because I just gave you no homework 2 days in a row and over the weekend.
Yes, sir.
Correct?
Yes, sir.
We need to come with a good attitude, not, we got to do the assignment today.
You gave us
Okay, we got to have
30 questions.
a good attitude about it.
That's 90 questions.
Prepared to work hard in class on the assignment and get it knocked out as quickly as possible. Can we do that for me?
Yes, sir.
Okay, any questions before I end the recording?
No.